This is section 3.1, and we begin a new chapter, and we're going to begin our study of quadratic functions. So we start out with this form, f of x equals ax squared plus bx plus c. And that's a parabola, and it's U-shaped, either up or down. So let's look here at a little bit of information. We have an axis of symmetry. That is an imaginary line that goes through the vertex of our parabola, and then it's the same on either side. This decreases till we get to 1. It increases from 1 on. Over here, the axis of symmetry in this one is x equals 0. Here it was x equals 1. It just goes straight through the vertex. The vertex here is 0, 4. Vertex here is 1, negative 3. So just general information. We have a vertex and we have an axis of symmetry. The leading coefficient, this a in our form, determines whether it opens up and down. If it's positive, it opens up. If it's negative, it opens down. It also controls the width of the parabola. So if we look here, the smaller the absolute value of a makes the graph wider. So this is like y equals 1/2 x squared. That's the red. Your basic one is the blue one, y equals x squared. The bigger the number gets, the narrower the graph. So here's 2x squared, so it gets that way. Same thing for the ones going down. All right, completing the square and the vertex formula. So this is the general form of a quadratic. We also have the vertex form or standard form. It's called both things. It looks like this. F of x equals a times parentheses x minus h squared plus k. And the vertex here is h comma k. You always change the sign on h because you're bringing it out of these parentheses. So if you're asked, and you will be asked to do this, to convert from general to vertex form, we're going to use completing the square to do that. So let's kind of go through the steps. So here is our general form. F of x equals x squared plus 6x minus 3. First step, and I've written the steps over here. Let f of x equal y. So we've changed that f of x to a y. And then we're going to move the constant over to the left with the y. We only want x things here. So now we have y plus 3 equals x squared plus 6x. We're going to complete the square on this part, meaning we want this to end up being a 3-term perfect square trinomial. In order to figure out what number's going to go here, we take half of 6, half of this middle term, that's 3. We square it, that's 9. Then 9 goes here and here. So sometimes you can think of this as the box method because it's y plus 3 plus a box equals x squared plus 6x plus a box. And the same number has to go in both of those because it's an equation. All right. So we clean that up. We have y plus 12 equals. Now, it's x plus or minus something squared. You match this sign, and whatever was half right here, this number 3, that's what goes in there. All right. Then you're going to subtract the 12 back to the other side. So now we've got it in the vertex form right here. We pull out 3 and it becomes negative, so that's negative 3. Negative 12 is our vertex. So that is a way to go from general to vertex form. Typically, I would say I want to use the calculator, throw that into y equals and find the vertex. But for this chapter, sometimes we're going to have to do this kind of work for sure. The other method is to use the vertex formula. The vertex formula says the x part is negative b over 2a. The y part is f of that, meaning you take whatever this number is and plug it in and you get the y. So let's do the same general equation, but use the formula. All right, so we have x squared plus 6x minus 3. And here's our a term, b term, c. So a is 1, b is 6, c is negative 3. So for the x part, it's negative b, so negative 6 over 2 times a, which is 1. That gives me negative 3. We're going to find f of negative 3, meaning we're going to plug that into our equation here. So we have negative 3 squared plus 6 times negative 3 and a minus 3. That ends up being negative 12. We got the same vertex as we did doing all of that work. So those are two methods to find the vertex for a quadratic, whether you're in the general form or the vertex form. And I think that's what we need to go to our problems. All right, here's our problem set. Number 1 says identify this as being linear, quadratic, or neither. If it's a quadratic, identify the leading coefficient and evaluate f of negative 2. When you look at the exponent, the highest exponent, if it is a 2, it is quadratic. If we put it in the descending order, our 4 is our a value, and f of negative 2 means plug negative 2 in. You do that here, and we get 27. So that's how we answer number 1. Identify this one. Well, we have an x here with an understood exponent of 1, so that is linear. Use the graph to find the sign of the leading coefficient, the vertex, the axis of symmetry, the intervals where it's increasing or decreasing, and the domain and range. Because it's going up, we know that sign on the a part is positive. The vertex is right here. That's at 0, negative 1. The axis of symmetry goes through the vertex at that x value, so it's x equals 0. It is increasing from here on, so that's 0 to infinity. It's decreasing from here to here, so that's negative infinity to 0. The domain is all reals, so negative infinity to infinity. The range, it begins at negative 1 and goes up. That'll have a bracket because negative 1 is included, and it goes to infinity. Number 4, we're doing the same things. Because this one is upside down, we know the sign of the leading coefficient is negative. The vertex is here at 2, 2. The axis of symmetry goes through that at x equals 2. It's increasing negative infinity to 2. It's decreasing from 2 to infinity, to negative infinity. 2 to positive infinity, so sorry. And then the domain again is all reals. The range is from negative infinity up to 2. All right, number 5, identify the vertex and the leading coefficient. Well, we need to, we can find the vertex here very easily, so that's 2, 1. The leading coefficient is negative 3. Now it says write that as ax squared plus bx plus c. So we have to do this squaring here. So negative 3 times, and if you square x minus 2, you get this. Then I'm going to multiply negative 3 by each of those, and then I'm going to take negative 12 and add 1 to it, and I get negative 11. So there's that answer. You do the very same thing with number 6. The thing to think about and notice is that this 1 is here. Let's put it at the other end. It's going to make it easier for us to see everything. All right, so we've now rearranged that. Let's go ahead and square this. We have negative 3 times x squared minus 6x plus 9. And then we'll multiply negative 3 by those. And we do the same thing, and we end up with negative 3x squared plus 18x minus 26. We know our vertex is positive 3. That changes sign. Positive 3, 1. And the leading coefficient is negative 3. Determine the quadratic function of the form here. Well, let's find the vertex. The vertex is at 3, -6. So we have x minus 3 squared minus 6. That's putting the vertex back into that form. Use this graph to write its formula. So we have to do a little bit more work here. All right, so the first thing we can notice is that the vertex is at 2, -5. So we'll write that down. That means h is 2, k is -5. And we think about the form, the vertex form here. So we can plug in the things that we know. F of x equals a times x minus 2 squared minus 5. We have to figure out what a is. We can substitute any point that's on the graph. So we get an x and a y. So I chose 0 and -3 because I see that right there. You could choose any point that you can tell what it is. So now I'm going to put the -3 for the f of x part equals a times 0 minus 2 squared minus 5. Then we will square this -2. That becomes 4. So we've got 4a minus 5 equals -3. Add 5 to the other side, so you have 2 equals 4 over a. Divide 4, you get 1/2 is a. So that was the part that we did not have. We had to put 1/2 here, and then we have the x minus 2 squared minus 5. All right, let's go down to 9. Use the graph to write this formula. It's the same idea, and we pick a point. We know the vertex. The vertex is at 1, 2. So we have that here. This is h is 1, k is 2. There's your vertex. And then we do the same process. F of x equals a times x minus 1 squared plus 2. Square that, you get 1a plus 2. So subtract 2 over there, you get -5 is a, and that's going to be -5 times parentheses x minus 1 squared plus 2. So just remember that process to find a when you don't have it. Number 10. All right, now 10 is a little bit more work, because we're going to be doing completing the square, but we don't have a 1 in front of this 2. So that becomes a little bit more work. All right, so here's y equals 2x squared minus 20x minus 5. We're going to divide everything by 2 because we need that to be a 1. So we have y over 2 equals x squared minus 10x minus 5/2. Remember, we added the constant to the other side. So we have y over 2 plus 5 over 2 equals x squared minus 10x. Now complete the square. So remember, we took half of -10 and squared it. So that gives us 25 to put in that box and that box. Over here, we've got, it ends up being x minus 5 squared, because remember, that was the half. And so over here, we're going to move this 25 halves. Hold on. So I didn't show that here, but you've got 5 halves and you got a whole 25. The 25 would be 50 halves. So 50 halves plus 5 would be 55 halves. We're going to subtract that to the other side here. We're trying to solve for y. So we have y over 2 equals x minus 5 squared minus 55 halves. Then we have to get rid of this 2, which means we're going to multiply by 2 on both sides. If I multiply 2 here, and let me just show that. Okay, so I've kind of shown that here. If I multiply everything by 2, those cancel out. I've got a 2 in front of this. These 2's cancel out, and that's how I end up with 2 parentheses x minus 5 squared minus 55. Little bit more involved, same ideas, same concepts. Number 11. This should This should be a little bit easier. We're going to do this, complete the square with y equals x squared plus 4x minus 9. We'll add the 9 to the other side. We have a box here, we have a box here. Half of 4 is 2, 2 squared is 4. I've put that over there. So that 4 goes there and there. We have y plus 13 equals x plus, remember whatever this half was is the number that goes here, x plus 2 squared. Then move your 13 to the other side. That is our new equation in vertex form, and the vertex is negative 2 and minus 13 because we changed the sign there. All right, number 12. State where the graph of the parabola is increasing, where it's decreasing. Let's go ahead and put that into our calculator, and we get it here. You can find the vertex by doing second calc, choose min, and follow the prompts. You will get 5 and negative 25, but you're interested in the x value. So it's greater, state where it's increasing. Well, that's greater than 5, and where it's decreasing is less than 5. Do the same thing with 13. All right, so we've got this, and we need to use the vertex formula. So a is 3, b is negative 12. X is negative b over 2a, so that's negative 12 over 2 times 3. And then if we do that, that's positive 12 over 6, which is 2. That's our x part of our vertex. F of 2 we plug into this here, and we end up with negative 4. So 2, negative 4. And if you just kind of sketch that at 2, negative 4, you can see it's decreasing for less than 2, and it's increasing for greater than 2. So that fills in that part. Number 14, find the minimum y value of the graph. Find the vertex either with this formula or on your calculator, and they want the y value of the vertex, the y value, and it is negative 12. Same thing with 15, find the maximum y value. You're going to find the max either with the vertex formula or the calculator. Number 16 is a regression question. So let's talk about this. There is a regression notes page in the yellow packet. The first thing you want to do is turn the plot on following those directions. Then we're going to go to Stat and Edit on your calculator, and you'll put the top ones, the x values in L1. You'll put the bottom numbers, the f of x, in L2. So that'll be that part. Then you will press Zoom 9, and it looks like I didn't write the word zoom right. Let's see if I can fix that. Okay, got that fixed. When you do Zoom 9, you'll get a plot of those points. It does look quadratic, and so we'll go back to Stat, over to Calc, and we'll choose Quadratic. We'll hit Calculate. You get these values. Okay, it says this is the form, and it gives you A, B, and C. Put that equation into Y1. Copy these exactly. And you know that plot is on because it's dark, so when you've turned it on, it'll be dark. But we'll put this here, and we'll put Y is 0, Y2 to be 0. You'll press Graph after you put it in, and you note that this quadratic line that we've got here really hits those points pretty well. All right. Now, our question said, estimate f of 3.5. So now that we've got our line, we can do second, calc, choose value, it should be the first one I think, and then put in 3.5. And f of 3.5 is here. It's the y value. And I believe it says to round to 2 places. So 56.02 is what we got out of that. So go over that regression. We will do that more, but use that regression notes page in the yellow packet and go through that, follow the steps. I've put most of the screenshots here for you, and that should get you going.